All right, so the reason that we're calculating probability distributions and talking about probability distributions is that they tell you something important about what data are actually likely to look like. And specifically, probability distributions tell you what pattern of outcomes to expect in a set of events. In other words, in a sample. So if you think back to the superheroes, if you wanted to take a sample of 5 superheroes from the basket, you would take that sample with 5 separate events, right? So you'd pull a superhero, you'd pull another superhero, you'd pull another superhero, you'd pull another superhero, and you'd pull another superhero until you had 5. But that sample would be created by these 5 probabilistic events of pulling a superhero out of the basket. And based on the probability distribution that we found for superheroes, we would know about what proportion of superheroes in our sample we would expect to be each of the different superheroes. And we can do the same thing with coin flips. So what we found in the last document camera thing was the probability of getting each number of heads in a double coin flip. So if you flip a coin 2 times, you have a 25% chance of getting no heads, a 50% chance of getting 1 heads, and a 25% chance of getting 2 heads. And of course, as we would expect, these things add up to 1 because there's a 100% chance that in your 2 coin flips, you're going to get either 0 heads, 1 heads, or 2 heads. But the thing I really want to draw your attention to here is the last column in this table, which is labeled expected relative frequency. What this means is that if you were to take a sample, so if you were to repeat this event until you had some sample of outcomes, you would expect 25% of those outcomes to be 0, 50% of those outcomes to be 1, and 25% of those outcomes to be 2, roughly. And the thing here, and something that's really important in thinking about sampling and probability, is that this tells you what you should expect, overall. But because of the randomness involved in probability, and the fact that you really don't know how a coin is going to land when it falls, means that your actual pattern of events may differ from your expected pattern of events. In other words, sample characteristics usually differ from the probability distribution just because of random chance. So if we're talking about coin flips, it's likely that you're not going to end up with exactly the same proportion of 0s, 1s, and 2s as you would expect just by chance. Same with superheroes. If we're expecting 18% of our sample to be made up of Iron Man, let's say you picked 100 superheroes out of a basket like that. It's possible that you'd end up with exactly 18 out of 100 Iron Mans, but it's not that unlikely that you'd end up with 17 Iron Mans, or 15 Iron Mans, or 20 Iron Mans, just by random chance. And so the relationship between probability and what you expect in a sample is that the probability tells you, what you should expect and what would happen if you were to, do this over and over and over again. But with any particular sample you take, it might be a little bit different from your expectations. And something else I'd like to highlight here is the importance of sample size. And specifically, the bigger your sample, the more likely it is that your outcomes are going to be close to your expectations. So if you were to do your double coin flip 10 times versus 50 times, it's likely that your proportions in your 50 coin flips are going to be closer to your expectations than your proportions out of your 10 coin flips. So I'm going to hop back over to the document camera now to talk about this a little bit more.